All right, senior math, welcome back. Um, Sorry if my voice sounds a little weird. My voice is pretty scratchy today. Um, so I apologize if that is the case. Today we are talking about something new. We're going to take an easy little lesson today. We're going to talk about hypothesis statements. And so hypothesis statements, thinking off of your warm up, we need to talk about what that word hypothesis means. So, in statistics specifically, a hypothesis is a conjecture about the population that may or may not be true of a sample set. So, essentially, in normal science or in any sort of study, a hypothesis is essentially a conjecture based off of limited data that inquires for further research. So, what that means is you have a limited knowledge about some subject and you make some sort of thing that you believe to be true, you believe to be a true statement, and it requires further research to test whether it actually is true or false. So that is what a hypothesis is. So anytime you are studying something in science class, or anytime you're doing a research project, or researching anything, you create a hypothesis first, and then you test whether that research is correct or not. So we do something similar in statistics. We have a statistical hypothesis, which is a statistical conjecture about the population that may or not be true. So when we mean about population, so some sort of population of some sort of sample set of some sort of group, you are making a statistical conjecture about. So typically, that is for the cases that we are going to be studying, it's going to be about the mean of that population. So the average score or rate or percentage of some sort of population. That's what we are going to be making hypotheses about. And then we are going to be creating some sort of statements on whether that hypothesis is true or false. And later, I believe on Friday this week, we will be testing those hypotheses. We will talk about how we can test whether a hypothesis is true based off the data received. So let's start off with talking about what the null hypothesis is. So a null hypothesis, null essentially basically means initial or starting value. We typically represent this by h sub 0. This little sub 0 is read as null. So this is h sub null, or h null, the null hypothesis. So a null hypothesis is a hypothesis that states that there is no difference between the two parameters. So a null hypothesis is essentially saying that my research proved that there is no difference between what we believe to be the mean and what the mean of our research came out to be. So the research and the actual belief came out to be the same. So the belief is considered to be normal, or whatever was the initial thought is true. So the null hypothesis means whatever the current belief is still around and still strong and still correct. While the alternative hypothesis, this is read as H sub 1, is typically how we write it. 1 being the alternative, showing it's different from H sub 0 or H sub null. So an alternative hypothesis is a hypothesis that states a specific difference between the two parameters. So there's some sort of difference between the current belief and what your research actually suggests. So the alternative hypothesis is saying that the current belief is incorrect. There's something different, whether the research suggests it should be greater than, or should be less than, or should be just different in some way. We'll talk about how we can tell that later. But the alternative hypothesis suggests that it should be different in some sort of way. There's some sort of difference between the current belief and what you believe the research to be. Now, we don't when we write these null hypotheses and these alternative hypotheses, we don't know if the alternative hypothesis is correct yet. We haven't tested it. We are just making the statement. We are making the hypothetical statements of whether they are correct or not, based off of what we believe, and then we can use that research to actually test it. We'll actually do some statistical measurements to show whether these tests are correct, or whether our research has enough information to prove to actually prove statistically that our data suggests a different hypothesis. All right, so let's look at some examples of writing down the null and alternative hypothesis from some scenarios. So, a medical researcher is interested in finding out whether a new medication will have an undesirable side effects. Currently, they are concerned with the patient's pulse rate. Will it increase, will it decrease, or will it remain unchanged after taking the medication? So that's our little scenario. So this medical researcher is interested in finding out whether the medication will have some undesirable side effects. Currently, they're concerned with the patient's pulse rate. Will it increase, decrease, or remain unchanged after taking the medication? Since the researcher knows that the average pulse rate is 82, the hypothesis for the test are H sub null, or the null hypothesis, is that the average is 82, and then the alternative hypothesis, H sub 1, is that the average is not 82, is not equal to 82. So let's talk about how they came up with these. So we knew that the average pulse rate of just any person, just the average pulse rate that a general healthy human should have, is supposed to be 82. So they don't know. So that's what the average the current belief, the average of the current belief is always going to be your null hypothesis. So our null hypothesis, H sub 0, is going to be the mean, mu, which is our symbol we always use for mean, is equal to 82, whatever just that result they told us. Now for our alternative hypothesis, the alternative hypothesis is always going to be different from the current mean, the null hypothesis. So alternative hypothesis, H sub 1, we don't know if it's supposed to be greater than. We don't know if it's supposed to decrease the pulse rate, increase the pulse rate, or somehow make it remain unchanged. Also, all we're assuming is that this medication it's going to have some sort of effect on the pulse rate. So the alternative hypothesis, the different hypothesis that we believe this medication is going to have some effect, we just assume that the pulse rate is going to change. The average pulse rate will no longer stay 82 after taking this medication. We don't know how it's going to change. We don't know whether it's going to be increase or decrease. We just assume it's going to be different. So we just assume it's going to be not equal to. So this symbol right here means not equal to. It's an equal sign with a slash through it. So we just assume that the mean is going to be not equal to 82. We don't know if it's going to be greater than, less than. We just assume it's going to be different. So that is your null hypothesis and your alternative hypothesis. So that's all you have to do for writing those down, making those statements. So a chemist invents an additive to increase the life of automobile batteries. If the mean lifetime of an automobile battery is 36 months, the hypotheses are, so we have the null hypothesis, H sub 0. So it says that the average is less than or equal to 36. So they got less than or equal to 36 because we said if the mean lifetime of an automobile battery is 36, and we are hoping to increase the life of automobile batteries, we want to show that the alternative hypothesis, is going to increase the average. So we want the average to be greater than the current average of 36. So our alternative hypothesis is going to be mu is greater than 36, which means our null hypothesis is just going to be less than or equal to 36. Our whole goal with this test is to hopefully show that it is greater than 36. So our alternative is going to be mu is greater than 36. A contractor wishes to lower the heating bills by using a special type of insulation in the houses. If the average of a monthly heating bill is $78, her hypothesis about heating costs with using the insulation are that the null hypothesis is greater than or equal to $78. The alternative hypothesis is less than or equal or less than $78. So if we know the monthly is 78 and we're trying to show that the average heating cost will go down based off using this insulation, we're lowering the heating cost, then we want to show that the average heating cost is less than or less than 78. And so that means the null hypothesis is going to be all the other values, the greater than or equal to that average that we were given, greater than or equal to 78. So those are the three scenarios we can get when we are testing hypothesis. So the three scenarios essentially are a two-tailed test, a right-tailed test, and a left-tailed test. And these are based off of how we write out the null hypothesis and the alternative hypothesis. So if the alternative hypothesis is supposed to be not equal to our null hypothesis, then that is going to be a two-tailed test. The reason being it's two-tailed is because if we look at our normal distribution curve, still using that normal distribution curve that we talked about, we look at our normal distribution curve, we have that mean is always going to be right in the middle. Now, we don't know if our new average is going to be above this mean or below this mean. But in order to statistically prove whether something is significant, whether there's actually a change, it needs to be far enough away from that mean to actually show significant value. And so we can use z-score to show this. So this is what we'll talk about on Friday, is if we can show that the new mean falls high enough or low enough in that z-score range that's outside of our typical statistical average, that's a high enough probability of a difference. So it's like one of those 95 percentiles in that 95% confidence intervals piece that we talked about. If we show that the new average is greater than or less than by 95%, then we can show that is statistically proven that the alternative hypothesis is correct. But if we can't show that, if the new average turns out to be somewhere in this range, in this red area, then we know that it is the null hypothesis is correct, and we're just going to keep the null hypothesis. Our research didn't show anything new; it just kept the null hypothesis. And so this is called a two-tailed test because there are two regions that I could potentially show up. I could potentially show up greater than my mean. I could potentially show up less than my mean. So it is called a two-tailed test because there's two regions. I don't know if I'm going to be greater than or less than. A right-tailed test is similar. I know that my mean is in the middle, and I'm trying to show that the alternative hypothesis is going to be greater than. So there's a region above this mean that I'm hoping to find with my alternative hypothesis. I'm hoping the mean of my research shows up in this section and not in my normal red section. If I show up in that normal red section, that's going to show that my null hypothesis is correct. My normal hypothesis is correct. But if I show up in that green section, that's going to show that my alternative hypothesis was correct. So if our research finds a mean here, then we know the alternative hypothesis is correct. If our research finds a mean here, we know that our null hypothesis is correct. So this is a a right-tailed test. So right-tailed test is because it's always greater than the mean. It's to the right of the mean in the greater values. Left-tailed test, you can probably figure out what that's going to be. That's going to be always less than our mean, always lower than. So our right-tailed test is always going to be our left-tailed test is always going to be to the left of the mean in the lower values of our z-score. So if we get data that suggests that our mean is lower than our average, it's a left-tailed test because our values are going to be less than the average. And same idea. Once again, our alternative hypothesis is going to be in that green area, H sub 1. And our null hypothesis is in that red area. Anything greater than or equal to my average. All right, so let's look at some examples and let's try to state what is the null hypothesis, what is the alternative hypothesis in these examples, and let's state whether they are a two-tailed test, a right-tailed test, or a left-tailed test based off how we write that null hypothesis. So once again, if our alternative hypothesis is not equal to, it's two-tailed. If it's greater than, it's right-tailed, and if it's less than, it is left-tailed. So that's all we have to look at is that alternative hypothesis to see what those are. All right, so a researcher thinks that if if expectant mothers use vitamin pills, use vitamin pills, the birth weight of babies will increase. The average birth weight of babies currently is 8.6 pounds. So we need to figure out what is our null hypothesis and what is our alternative hypothesis. So our null hypothesis, let me actually copy. Let me copy this so I can not have to type this up a bunch of times. Okay, so we have our null hypothesis and our alternative hypothesis. So we are trying to show that the birth weight of babies will increase increase. So we are showing that we are hoping that our alternative hypothesis is going to be greater than the current average of 8.6, which means that our null hypothesis, if our alternative hypothesis is showing that it's greater than, then our alternative hypothesis is trying to show is going to be the opposite, which is going to be less than or equal to, if I can find my symbol, less than or equal to the value of 8.6. So because we are showing that it is greater, this is going to be a right-tailed test. And we'll talk about how to do those tests once again on Friday. But this is going to be a right-tailed test because we are showing that we are greater than. Let's do another example. All right, let's get rid of this. Get rid of this. All right, an engineer hypothesized that the mean number of defects can be decreased in a manufacturing process of CDs by using robots instead of humans for certain tasks. The mean number of defects per 1,000 or per disk of 1,000 is 18. So an engineer is hypothesizing that the mean number of defects can be decreased. So we are trying to lower the mean number of defects. So our alternative hypothesis, we are trying to hopefully show that our alternative hypothesis is lower than the current average for every 1,000 disks, which is 18. Which means that our null hypothesis, once again, is going to be the opposite. It's going to show that it is greater than or equal to 18. If we get anything greater than or equal to 18 for our average, then we know our null hypothesis is correct. But if we get anything that is less than or equal to 18, or sorry, less than 18, not equal to, because equal to is still the average. If we get anything less than that current average, then we show that our alternative hypothesis is correct. So because it's less than, we are trying to find the area to the left of our curve. If we think about our z-score, we're trying to find the area to the left over here of this value. So that's going to show us that it is a left-tailed test because we want to be less than. So one little trick you can think about is less than is left, greater than has an R in it. So greater is right. I don't know if that helps you at all, but this is a left-tailed test. And lastly, all right, a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean score was 73. So we assume that the results are going to change, but we don't know how they're going to change. We don't know if it's going to be greater than, we don't know if it's going to be less than. So because we assume the results are going to change from the average, but we don't know how, we just want to show that they are different. So in order to show that they are different, we just have to show that the mean is not equal to our current average of 73. But if we get somehow that the mean is equal to that current average of 73, then we know our null hypothesis is correct. So if we can show that our alternative hypothesis is the mean is not equal to 73, then we know it's going to be different. But if we do get 73, then we know our alternate or null hypothesis is correct. So once again, because it's not equal to, we are showing that it's either above or below. We don't care if it's above or below. We just want to show either of the two. So this is a two-tailed test. And that is how we write out our hypothesis statements for those different scenarios. So once again, this stuff's pretty easy. It's just really identifying and dissecting the words in the statements, and then turning it into the alternative hypothesis and the null hypothesis, and then stating whether it's a two-tailed test with not equal to, a right-tailed test if you're greater than, or a less than test, a left-tailed test if it's less than. So that's all what we're really looking for. You'll have a little bit of practice over this, but it's pretty short, pretty quick. I think you guys will get it super quickly, and that's where we'll finish for today. Let me know if you have any questions. Have a great rest of your day.